Hello everyone. Last class I talked about relative configuration and I said this class will be talking about absolute configuration. But I thought before I start absolute configuration, let me brush back again topic of conversion of Sauer's projection into Fischer projection formula. So this formula which we have seen so many times, they are called as Sauer's projection formula. It is three-dimensional representation of molecule. You exactly know that this CH3 and this hydrogen are on the paper. And this Cl is coming out towards the viewer. It's not in the plane, it's towards the viewer, coming out of the paper, okay? And this bromine is going inside the paper, under the paper. It is below the plane, okay? This paper is the plane, so Br is below, under the paper. Now, if it is having only one chiral center, it's alright. But if you have more than one, it becomes very, very complicated to explain and represent. So Emil Fischer, he was one of the most genius organic chemists of all times. He came up with this representation called as Fischer projection formula. He said, what if we present them as two dimension? And then he came up with this kind of formula. So we'll see how can we convert the Sauer's into projection and into Fischer and Fischer into Sauer's. So if you see this molecule, this is Fischer. It is two dimensional. You can see this is on the plane, this is on the plane. But just that we write it like this. What he actually means is, we never show like this, okay? It means this is what it is, right? But we always draw it just two simple lines. But what it means is the horizontal line is towards the viewer and the vertical line is away from the viewer. Please, you cannot forget this, okay? This is the most important sentence about this. So whatever is straight, whatever is horizontal, which is lying down like this, that means it is towards the viewer. This Cl and Br, this Br is towards, coming above the paper, and this Cl is also coming above the paper, okay? Whereas this hydrogen and this CH3, they are going behind the paper, they are below the plane. So I can draw it something like this. This Br is towards the viewer, this Cl is towards the viewer, and H is away from the viewer, and CH3 is away from the viewer, okay? Now how do we convert? So we'll show, if you have a simple Sauer's projection formula, they want you to put into Fischer projection formula. Always remember this, okay? Always remember the two substituents which are in the plane. Remember this. The two substituents which are in the plane, they go in vertical line. And the two substituents which are towards the viewer and away from the viewer, they go in horizontal line. That means these two which are in the plane, they go in vertical line. That means they go away from the viewer. And these two substituents, which one is toward the viewer and is away from the viewer, they go in the horizontal line. That means they are towards the viewer. Very, very important. So what it does is basically, you understand this part. This CH3 is in the plane and this hydrogen is also in the plane. So you catch hold of CH3 and rotate it 90 degrees so that H goes exactly behind. And then what you are getting is, and then you push it little. So what you are doing is you are catching the CH3 and turning it around. So CH3 remains on the board, on the paper, but hydrogen is going away, is going below the paper. And then you push it little like this so that CH3 and hydrogen both go away from the viewer. Now when you have rotated this, what has happened? Your Br was away from the viewer. Imagine Br is your index finger and Cl is your thumb. So it was away. Now when you rotated it like this, now both of them came towards the viewer. But since Cl was up, it went towards the left side, and Br, which was behind, came towards the right side. Is it very clear? So what has happened is basically your Br has come front, your Cl has come front, and this CH3 and H has gone both behind, and you are getting this. Is it clear? Similarly, if they give you like this Fischer projection formula, here both the planes were on the left side. Now here both the substituents which are on the plane on the right side. Again what you're doing, again remember this, these both the two substituents which are in the plane, the two substituents which are in the plane will go in vertical line. That means they have to go away from the viewer. Very, very, very important. Okay. So what you're going to do is you're holding this CH3 and turning 90 degrees again. So what happens? The CH3 remains there, but hydrogen goes behind. And then you are having something like this. CH3 is there and hydrogen behind, and you push it a little behind so that this CH3 and this hydrogen both go a little behind. And what happened to this OH? OH was front, ET was behind. You rotate it around, so OH comes on the right side and ET comes on the left side, and you get this. That is same as, you never write this in examination, you never write it anywhere. This is just like to understand, but basically what you can show is these two lines. When you show these two lines, it means that only that vertical line is away from the viewer and horizontal line is towards the viewer. Sometimes people can ask you crazy questions, something like they will ask you this and they tell you to make Fischer projection formula. Now again, this very easy. What you want again, basically you want one horizontal line, one vertical line, one horizontal line. Vertical lines means both of them have to be away from the viewer. Horizontal line means both of them have to be towards the viewer. What you do is, you understand this molecule first of all. This H and this OH, they are both in the plane of the paper, and this Cl is coming exactly front. It is like two V's crossing each other. This Cl is coming front and Br is going back. You are having something like this, okay? And you are having something like this. Two V's are there. So what I am doing is I'll just lift it like this, turn it like that, okay? So it's like I am catching hold of this OH and turn it like this, so that OH comes up and this H comes here. So when that happens, this Cl and Br was there, so they were up, now they have turned here. So same thing, Cl was towards the viewer, now also it is towards the viewer. Br is away from the viewer, now also it is away from the viewer. Now you just rotate it 90 degrees. So when you rotate 90 degrees, what happens? This OH and H again goes behind, and this Cl comes towards the right side and Br comes towards the left side. I have told many times in Fischer projection formula, the vertical line means away from the viewer, horizontal line means towards the viewer. So this is like, you can write it like this. OH, write H here, and you write here Br, right here Cl. Okay. Now these are the two assignments which I want to give you. Please do it, and if you don't understand, ask me immediately, call me up and I will tell you. I want you to convert these two Sauer's projection formula into Fischer projection formula. It's very easy. Understand, what you have to do is you have to put it in such a way that vertical line is away from the viewer and horizontal line is towards the viewer. Okay, please do it. I want it in the notes. Right. Now we are going reverse way. We are going to do from Fischer projection formula to Sauer's projection formula. So imagine something like this is there. Knowingly I have given you this abbreviation, so you should know in organic chemistry these are very important. When I write Me, Me means methyl, so it is CH3. When I write ET, ET means ethyl, so it is CH2CH3. When I write pH, pH means phenyl, that means benzene ring is there, and PR means propyl, so CH3, CH2, CH2 is there. Okay. So now it is asking you to convert this into kind of this. Okay. So first you have to understand what it means. What it means is this is a vertical line and this is horizontal line. Vertical line means away from the viewer, so I am putting it like this. See, I am not drawing it very properly, but this, when you start, it should be small, and when it goes towards, it becomes bigger, the line becomes bigger. Okay, so this Me is bigger, Me and ET, they are away from the viewer, but they both are vertical. Okay, it's something like this. It is this Me is my index finger and ET is my thumb. Okay, and this horizontal line is towards the viewer. It is something like this. So thumb is pH and profile is index finger. Both of them are towards the viewer. Now what I can do? First you push it little front. You understand what is happening is both ME and ET are behind. I will try to put it so that ME comes in the plane. So I'm just like that. I'm pushing this ET so that this ME comes up. So ME comes in the plane. ET goes little more behind. The angle remains 109 degrees. And this PR and PH, which were like directly focusing towards you, now they have bent down little. Their head is down. Now what it says is, now you turn it, you catch hold of this ME and rotate either this or this. So if I rotate it this way, what happens? This ET was back. Okay, it is like this. H is there, ME is there, and ET is there. You turn it like this. So ME remains in the plane. ET, which was away from the viewer, has come in the plane. So you are catching hold of this ME and you are rotating it like this 90 degrees. Okay, so what happens? This ME remains here. This ET, which was behind, has come in the plane, right? And what had happened here? Here you are having pH. Here you are having pH towards the viewer and profile towards the viewer. When you rotate it, what you get is pH goes away from the viewer and PR comes towards the viewer. You understand? So you're getting PR towards the viewer and you're getting pH away from the viewer. And you are getting this this formula. This is Sohor's formula. Okay. Or if you want this both plane rather than on the left side, if you want on the right side, what you can do is, I'm just making it again what you have done here and here. And then you catch hold of this ME and you're rotating it like this. So that ET was there, that comes here, ET comes here. And then what happens? Your PR was there, PH was there, they rotate it like this. So PR goes away from the viewer and PH comes towards the viewer. Okay. This is the assignment I want you to do. I want you to convert this Fischer projection formula into Sohor's like this. I want the two planes on the right side. And then I want you to do another molecule. This again here CLM is there. I want you to convert so that these two plane has to come on the left side. Remember always the vertical line. The vertical line always forms in the substituents in the plane, and the horizontal line always comes towards and away from the viewer. So last one example I'll give you, and then with that I'll finish this topic itself. This one I am not going to tell you, you do it yourself. If you get doubt, you ask me, I'll tell you that time. This one I'll solve for you. What if teacher, somebody asks you crazy question, he says that no, I want this to be shown like this also, like this also, like this also, right? These are important so that you really understand these molecules exactly look like this. If you do these questions, if you are able to do this molecule, if you are taking out crystal structure of this molecule exactly looks like this. Okay, so they are like that. We are not thinking and imagining and doing things. They exactly look like this. Okay, so I want to convert this way. What do we do? What do we do? Okay, so this was the question which has been given. So one thing is very clear, whatever is in vertical line, they have to face away from the viewer, and whatever is horizontal line has to face towards the viewer. I want something like this. Okay, so what I am doing is, you understand this how it is. This PH and H is away from the viewer. Okay, it is going behind, and this ME and CL is there towards you. If I push it something like this, so what happens? Both ME and CL comes in the plane, and this you are having PH and H like this. I am making them sit like sawhorse. So what is happening is PH is coming front and H is going behind. Now if you rotate it 90 degrees, then what happens? This PH which was front is coming on the paper. This H which is away from the viewer comes on the paper, and this CL coming towards you or coming away from you. Please practice this. Do it without seeing. If you are able to do this, means you have understood. If you are not able to do this, then there is no way you can proceed forward. You have to understand this topic. Okay, any common book will give you any internet, every website will give you all this. But how many ever times you see, unless you practice, you will not get it. You have to practice it. These examples are enough. If you are able to these many examples, you will be able to do any molecule which has one chiral center. When more than one chiral center is there, it becomes much more complicated, which we will do future classes. Right. Imagine this molecule is there now. Same molecule. I wanted to put like this. The two in the plane has to come on the right side. So again, what you do is you are putting it like this. H is away from the viewer, pH is away from the viewer, Cl is towards you, M is towards you. Then what I do is I pick up this H which is away. I pull it up, tuck like that, so that H comes on the plane. pH was already behind, it goes little more behind. So pH is away from behind. And these two Cl and Me were there, they bow down. So we are having Cl and Me. Okay. And then what happens? Then from here I have drawn it here. Then I want to, I'll just catch hold of this hydrogen, rotate it 90 degrees. So pH comes here. The Cl which was there towards this side has gone towards the viewer. Me has gone away from the viewer. And if I want to put it like this, so again same thing, I'm picking it up here and I rotate it like that. So hydrogen remains here, pH comes here, Me comes here, Cl comes here. Please practice. This is the one of the toughest topic. After this we'll proceed to next topic. Okay, thank you.